So today we are going to talk about MCP. So MCP has been out for a year, and in that time it has gone from a quite entropic spec to the most talked about protocol, especially in the AI space. So over a million developers have already looked at it. GitHub has is full of MCP servers. Every AI company is adding support towards it. But here is what I'm seeing, especially on the enterprise side. The enterprise side still seems a little confused. They don't know, they don't understand where an MCP starts and where an MCP ends. And it is causing a lot of confusion, and that is leading to slow adoption. So today I want to cut through that, and by the end of this video, hopefully you get a clear picture what MCP gives, what it does not, and what a real enterprise implementation looks like on AWS. Now before we get into this video, quick introduction about myself. My name is Mahesh and I've been building AI-based applications for almost 2.5 years now, and hopefully some of these videos help who's just getting started. Now let me give you a concrete scenario. Imagine you work with 6 different federal agencies. Each one has a Jira instance for ticketing, a Slack workspace for communication, a Postgres database for operational or enterprise data, an S3 bucket full of documents. Now they all want to build AI powered chat application, whether it's their enterprise cloud or a custom homegrown chat application, but they want their LLM to talk to this different systems. Now without a standard, every agency will build their own integration, its own auth patterns, its own error handling, its own quirks. 6 agencies means 6 times the work, 6 times the maintenance, and 6 times the risk. So remember those 24 custom integrations what I spoke about. MCP kind of like collapses that to one. MCP or Model Context Protocol is an open source standard for connecting your AI applications to external systems. So in short, MCP gives every client and tool like a shared language so that they can talk to each other. Now let's go back to that Jira example what I gave, where every agency was trying to build a custom connector to connect to Jira. Now what can happen is one of the teams can take a lead, build an MCP server out of it, and as long as other models LLM client it understands the MCP language, then it can connect to the same MCP servers. So build once, connect every time. Now let's look at some of the key components which constitutes the overall MCP architecture. Now it uses a simple client-server communication. The key components are MCP host, MCP client, and MCP server. Now MCP host is your AI applications where multiple MCP clients live. MCP client is a component which connects to the MCP server and gets context out of it. An MCP server is where you build the capabilities using primitives like tools and resources. So it's a simple architecture. Now we have defined what MCP means. We understand some of the key components, the client server architecture, the connection. Now let's see what MCP does not do, and this is where enterprise teams usually get stripped. MCP on its own just provides the protocol to connect your AI applications to external capabilities. That's all it does. It does not give you authentication. It does not tell you your authorization mechanism. It does not give you any kind of auditing mechanisms, multi-tenancy, governance, rate limiting, etc. So these are some of the things which you have to build on your own. So in short, MCP just handles the contract the standardized way for client and server to talk. The rest is just an engineering problem which you have to solve. So in short, you have to build your registry, you have to build your authorization server, you have to build your auditing mechanism, and if there is a need for multi-tenancy, that's also you have to build. Now hopefully that clarifies the confusion with enterprise and what MCP does and what MCP does not. Alright, so now let's look at a concrete example using AWS, and this is like a notional architecture, and there are many ways to design this. If I have to build this, I will start with something like a control plane. Now this is like a central governance layer which will be shared across the 6 federal agencies in our example. In this, I will start with something like an MCP server registry. So meaning an agency can build their MCP servers and they would register in this common central place. Then I will also have something like an MCP host registry, which will allow us to have some sort of access pattern between which host will have access to which MCP servers. Then there will be a central authorization server, because you want to ensure that the client and the server communication is secured using proper OAuth 2.0 standard. Then there will be like an audit and monitoring layer. In this example, you can use something like CloudWatch, CloudTrail, X-Ray. This is to ensure that we capture all the metrics and logs. Then the federal agency layer, what you see is where actually the host and the MCP server is deployed. You have a choice of deploying it using an ECS cluster or Lambda function. You also want to ensure that you follow the right MCP protocol spec, and also download the right SDK while building the MCP depending on the programming language. So once you do this, you can deploy them as ECS cluster or a Lambda function. Last but not least, we also need to look at the OAuth 2.0 client credentials flow, and it's important to understand. Now this is when the host that registers in the host registry, you also want to register that as a client incognito. Now this gives you a proper client ID and client secret. Think of this as an identity of your host. Now this is used when you call the MCP server. Your host would go to Cognito and give the right client ID and the secret, and it gives a token in return, and this token is passed to the MCP server, and MCP server then would validate this token using a public key. And that's why you ensure that the communication between the MCP client and the MCP server is secured. Now once the secure connection is established, the client can then access the server tools and resources what the MCP server provides. Now what you see is like each agency now owns its own server, it owns its own host, but they share the governance, the authorization and the audit trail, and that separation is exactly what makes this work in the federal multi-agency setup. Alright, so in this video you saw what MCP does, the connectivity layer, the protocol, the server host client model, and what it does not: authentication, authorization, auditing, governance, rate limiting, etc, etc. You still need to build those. If you want to see more videos on AI architectural patterns and how to build them right on AWS, hit subscribe. Until then, bye.